Dr. Nettie Stevens broke down barriers for women and opened up doors of knowledge for all humankind. She decoded the science between the two genders. A pioneering cytogeneticist and researcher at Bryn Mawr College, outside Philadelphia, Stevens discovered in 1905 that sex is determined by hereditary traits passed through chromosomes. Females are born with a pair of XX chromosomes, inheriting an X from both the mother and father. Males are born with XY chromosomes, the X is from the mother, the Y from the father. Stevens further discovered that the determinant X or Y chromosome was passed through the father. Stevens studied insects. But the same chromosomal factors have proven to determine sex in most species, including humans, on the planet. Humans have 23 pairs of chromosomes. One pair, known as the sex chromosomes, determines male or female gender. It's settled science today. But her work revolutionized the burgeoning field of genetics at the turn of the 20th century. She was a real prodigy. Gregory Davis, an associate professor of biology at Bryn Mawr today, told Fox News Digital. More importantly, perhaps, he said, she had guts. Research fields such as biology are still dominated today by people with Y chromosomes. An XX carrier in the field was positively extraordinary more than 100 years ago. Stevens was more than just a symbolic female figure, however. She brazenly challenged the assumptions of many powerful people in biology, including her own colleagues and powerful mentor, Thomas H. Morgan. Aristotle. Even more dramatically, Stevens solved a mystery that had eluded the greatest minds in the world for thousands of years. The differences between male and female in form, function, physiology, and many other factors were obvious in humans and in most other species for millennia. Scientists long suggested environmental or circumstantial factors determined the sex of a child. One of the most famous minds of the ancient world claimed that heat was the primary force in sex determination. Aristotle's advice for older men looking to produce a male heir: have sex in the summer, author Rachel Swaby wrote in her 2015 book, Headstrong, 52 Women Who Changed Science and the World. Aristotle's theory sounds like folk medicine hokum today. But the leading science in sex determination had changed little from ancient Greece to the day Stevens entered the lab. Environmental causes were still the leading theories behind gender determination. Stevens' sex chromosome discovery was the culmination of more than 2,000 years of speculation and experiment on how an animal, plant, or human becomes male or female, Stephen Brush wrote for the History of Science Society in 1978. The indomitable spirit of Stevens would face one final challenge after she solved the eternal mystery of the sexes. She never quite got credit for her work at the time because, among other reasons, she did not have a Y chromosome. Nettie Maria Stevens was born on July 7, 1861 in Cavendish, Vermont, to Ephraim and Julia Maria Adams Stevens. Both were apparently from long-time Massachusetts families. The Civil War began to tear apart the nation just 3 months before Stevens was born. Her family soon suffered its own tragedy. The future genetics pioneers had just turned 2 years old when her mother died of unknown causes. The family moved to Westford, Massachusetts, where Stevens eventually proved a standout student at Westford Academy, a public school, despite its name, still in existence today. She was reportedly one of only 3 girls to graduate from the high school in more than a decade. She was obviously brilliant and worked very hard, said Davis. But even then, options for brilliant women were limited. Stevens became a schoolteacher in Lebanon, New Hampshire, but still burned with greater intellectual passion. Incredibly, well into her 30s, she moved all the way across the country to study at the upstart New Leland Stanford Junior University in California, now Stanford University. Stevens was finally able to pursue biology, according to author Swaby. She spent much of her lab time corralling protozoa. As an undergraduate, she discovered 2 new species, slotting it into the new genus of ciliates. Stevens, in other words, was already stretching the bounds of known science. She received a bachelor's degree in 1899 and a master's degree in biology in 1900. Her future, and her contributions to science, would be forged at Bryn Mawr College. The All-XX school offered rare opportunities for women in science. Writes Swaby, Stanford provided a solid foundation in biology, but Stevens was a rising talent, drawn to the cutting-edge research happening back east at Bryn Mawr. The small Pennsylvania college was a hub for genetics research. Stevens blossomed at Bryn Mawr, under the tutelage of Thomas H. Morgan, and Edmund B. Wilson, who went on to Columbia University but remained collegial with the upstart scientist. She received her Ph.D. at Bryn Mawr in 1903 at the age of 41. She had risen at a time when women in her hometown rarely graduated from high school to hold a doctorate in science and stand on the cusp of great breakthroughs in science. Stevens was working at an incredible time in genetics. Gregor Mendel, an Augustinian friar in Europe, had pioneered genetics research in the previous century, but his work was only discovered around the world in 1900. Protozoa. Mendel established the laws of inheritance, said Davis, the Bryn Mawr biology professor. At some point there was a suggestion that the factors that Mendel was talking about could be associated with things people could see in cells called chromosomes. Stevens began looking into the theory to see if hereditary traits such as sex were in fact passed on through chromosomes. The work was far from glamorous. The study involved plucking the tiny gonads from mealworms, beetles and butterflies and fixing them in a solution, Swaby reports. Stevens then secured the preserved sex organs in paraffin blocks in order to slice them into thin pieces without crushing the structures. When it was done right, Stevens could see a whole line of chromosomes laid out before her. Stevens published her extraordinary findings in a 1905 report called Studies in Spermatogenesis. The science in it was clear-cut and revolutionary. A mystery that eluded the greatest minds in history had been solved. The world of academia, however, is not so cleanly constructed as the building blocks of nature. Wilson drew the same conclusions about sex determination via chromosomes independently the same year and even peer-reviewed Stevens' study, said Davis. There remains debate over who actually made the discovery first. Glory in the arena, and credit for sex determination in the eyes of history, however, would later go to Stevens' former mentor. Thomas H. Morgan won the Nobel Prize in Medicine in 1933 for his discoveries concerning the role played by the chromosome in heredity, in the words of the Nobel Foundation. Morgan made additional advances in the field. But his global honor was built on the breakthrough that Stevens made years earlier. The irony, Davis said, is that before he had a religious conversion to chromosomes determining sex identity, Morgan was an opponent of the idea. He eventually comes around, but not until he finds the same phenomenon studying fruit flies. Nettie Maria Stevens died on May 4, 1912, in Baltimore after battling breast cancer. She was just 50 years old. Perhaps Stevens would have won a Nobel Prize on her own, she had only lived longer. Instead, her brilliance was devoted to scientific research for less than a decade. She started old and died young. Yet she left an outsized impact on the advance of gender research. Stevens has in recent years begun to achieve the recognition that evaded her in life. She's been the subject of, or featured in, several books. Women in Science, 50 Fearless Pioneers Who Changed the World, was published in 2016. Stolen Science, 13 Untold Stories of Scientists and Inventors Almost Written Out of History, was published in 2021. Both were written for young readers. Stevens was inducted into the National Women's Hall of Fame in 1994. Westfield State University in Westfield, Massachusetts, where she first began her college studies before going to Stanford, dedicated the Dr. Nettie Maria Stevens Science and Innovation Center in 2017. For a lot of our students, she continues to serve as an inspiration of a woman who persevered in face of the odds, said Davis, the professor at Bryn Mawr, which remains an all-women's school. Few people praised Stevens more than Morgan, the mentor who went on to win the Nobel Prize. He wrote a powerful obituary, famous in the field, following the death of Stevens. Her single-mindedness and devotion, combined with keen powers of observation, her thoughtfulness and patience, united to a well-balanced judgment, accounts, in part, for her remarkable accomplishment, he wrote.